fact, agricultural engineer, professor of the Granma University in Cuba.
No, ya lo tengo listo. Sí. You are sharing. Yeah. Ahora sí. ¿Se te verá? Sí. Adelante. Bien, muchas gracias, Tomás.
Thank you, Thomas. I will be starting my presentation telling you that the Granma University, as other Cuban entities, doesn't have integrated solutions to provide wireless access to the users through Wi-Fi networks built from access points managed by a central controller. In fact, this is not only about Cuban entities. I have participated and I have been in other academic institutions in Latin America, even large institutions in Latin America. And when you reach these places, you see that the authentication systems are local universities and the other devices that have different passwords in the different buildings. So this is a serious security issue because in the event of an issue, you cannot do forensics. So this paper seeks to use individual legacy devices, the obsolescence of which shows that, among other aspects, there are limited options for authentication for the users and the interaction with LDP servers and the compatibility with captive portals. So this solution has the goal of enhancing Wi-Fi connectivity in the different campuses of Granma's universities using Wi-Fi routers, legacy Wi-Fi routers. This is so that the user's authentication can be integrated to the data service of the institutions for which the Active Directory of Microsoft Windows servers is used. So it is necessary to deploy or use specific tools for managing this system. So basically, the solution that we found had consisted of two stages. The first stage involved designing and implementing the system for user authentication that would access the Wi-Fi network. The main idea of this initial stage was that the legacy Wi-Fi routers, the older routers, in general limit the security options and authentication options to local users or to the use of radio servers, Ethernet address filtering, among others. As the existing directory service at the university is Active Directory of Windows servers, the resulting option would be used to a radios that authenticates against the Active Directory. So initially, the idea came up, always seeking to do things as simple as possible, of using the radio's implementation of Microsoft itself. However, we wish to have a more configurable and adaptable system to different environments and capable of working with other user authentication systems and not only with Active Directory, for example, other LDAP implementations and other directories. So this experience had the intention of make this capable of being extended to other universities or entities of any kind, because this problem is not limited to my country and to my university. So based on these criteria, we selected Free Radius. This is because this is open source software, so the use can be done rapidly without delays and looking for budgets and signing contracts. So Free Radius has several plugins, and this is a widely configurable use, most versatile. It provides a lot of options and integrates many user authentication options. It can even generate a large amount of information in user registries, TXT files that are standardized by the relevant RFCs. It contains a lot of information and very easy to interpret. The files generated by Windows are not like this. So this is a very stable system that is widely documented and widely used worldwide. This is a basic scheme of the solution. Please pay attention to this device over here. So please pay attention to the software router on the left of the slide. The software router containing the captive portal. And I would like to say that the Wi-Fi routers, the ones that you have at the bottom, work simply as transport devices. They don't even play the layer 2 role of the network, just as a wireless switch. So these devices are connected to Wi-Fi networks. These Wi-Fi networks have the portal, which is a software router, which I'm asking you to focus your attention to. When a user is authenticated, the credentials provided by the users are forwarded to the Free Radius, and this authenticates the user with the Active Directory. The software used to implement the captive portal is Cova Chile, in charge of the assignments of the networks and to the users and the auto-configuration processes. This is Linux-based, and this firewall is Linux-based and doesn't exclusively carry out the functions related to Wi-Fi networks at the University of Granma. This works as a device that practically interconnects all the networks of the university, and the university is an entire province as well. So what I wanted to mention is that we had to adapt this topology. We had to adapt this existing configuration to a Wi-Fi system and not the opposite. That is why we used a second router. The second router is based on Cairo control because the university has a license to use this system. This is very much configurable. It can be managed through a web interface that is very easy to configure, and it provides registers through this same interface that are easy to interpret and to analyze. This carrier control, you can see, is up there at the top in the demilitarized zone of the university. The use of this second router is also justified based on several criteria. Hadn't we used this router, this would have implied that the address translation would have corresponded to the router firewall that I asked you to look at previously. This implies an additional workload for this device. In addition to this, the Cuban standards and laws require storing the records of access in public networks for a period no less than 6 months. And this firewall has an IP table. We're now migrating to an NF table. Now, the amount of records produced by the IP table is enormous. It's about 5 gigas a day. If we multiply that times 6 months, it would be practically very difficult to achieve this because the storage space is very limited. So we needed to increase the storage capacity. And finally, the interpretation of the registers generated by the IP table is quite complex and uncomfortable to process. The solution also implied using a typical forwarding by origin. The software router I mentioned created an additional routing table. The additional routing table only for the traffic coming from any of the Wi-Fi networks. This routing table basically would have the same routes as the main routing table. The only difference is that the portal, the portal to the link would be to the IP of the Cairo router, so that the translation for the outbound traffic to external routers would be done through this carrier control. This slide shows the different routes created in the routing table, which practically are the same contained in the main routing table. But I want highlighting here in red a set of permanent rules that were created. These show that the traffic coming from any of the Wi-Fis is then forwarded to the Wi-Fi routing table. At this stage, the idea might come up regarding why the captive portal was not better located in the carrier control device instead of the PC router, and thus removing additional traffic from the PC router. But it turns out that the carrier control version with which we worked doesn't have a captive portal. So this version has been designed so that this type of services provides comprehensive services linking very specific hardware devices that I never managed to see that specifically work with carrier control and are produced and sold by the company that produces a carrier. And it turns out that we didn't want to have new routers. We didn't wish to buy new routers. We wished to use the enormous amount of routers that we had and were not being used. So the objective was exactly the opposite. On the other hand, this is not just about one Wi-Fi network. The Grandma University is present in 3 different campuses in an entire province and has several headquarters. The solution was varied. Normally, the extensions shared the VLANs and used the same VLANs of the Wi-Fi's of the major headquarters, and they did have their only portal, which was one that provided access and where the routing tables were located. Now, at present, there are several management systems based on free radios, such as dollar radios. And this is the second phase of the research, And I want to mention that as regards this one, many might think that this might not have been so necessary because there are many systems that integrate free radios with management. But we did analyze many of these, and we specifically focused on Dalo radios. It turns out that instead of being very powerful and many options, despite this, all these systems that are free integrate the management and processing systems in a centralized database. I wanted to do exactly the opposite. I didn't want to have that integration. These systems didn't meet the expectations. On one hand, a modular solution was sought so that the authentication process was totally independent from the management process. This would then facilitate using the authentication solution with multiple management systems.
So that's one hand. On the other hand, we always they also always contemplated that if if that were not considered, then the authentication would not be impaired. The priority process, that is authenticating users, would continue to operate so that it would be transparent for users. And then when normal operations could resume, then it would update all of the information. So based on that, all the management system was developed so as a free radio would um, have all the text files, and that the management system would limit to process it. And it was developed in the Granma University. Basically, we import the registries as TXT to free radios. No, to MySQL. A database in MySQL, and with the assistance of the system created, we can determine aspects for a period of time defined by the user, or else daily or weekly or monthly or annually aspects such as the connection time per user, the number of connections in a period of time by a user, the traffic volume generated, the number of failed connection attempts, the users with more connection time, aspects related to the IP protocol of each interconnection established by each user, among others. The database is includes 9 tables normalized in the third normal form. The architecture was based in the MVC pattern, supported with co-igniter. And as a result, we can say, and this result is a bit old, more than 20 new areas of the university at present have Wi-Fi coverage. I would dare say that 40 at present, because after this experience, I managed to connect legacy router and older routers even abroad, and I brought them to my country, and it remarkably expanded coverage. This proposal is also being used and very successfully in many Cuban universities and some institutions of a province, and the curious thing is that in no case did they accurately reproduce what we had done at the university, but rather we used variants using this philosophy. Of course, we managed to have a more stable service with a better control, as there is a tool that enables the oversight and to manage the normal operations of the system.
Informes en formatos compatibles.
We can also manage the management tool also allows to generate reports very easily in formats compatible with Excel or PDF. And finally, I would say that at present, thanks to the use of legacy Wi-Fi routers, we have increased the coverage to access the networks through mobile devices at the university. And the Granma University Network Department has the free radios log, an IT system that favors the checking and the authentication services of the users that access the wireless networks. And this tool will give us a lot of statistical data with regard to the real use of these services. So this is what I had to offer. Any comments will be well received. Any questions for Manuel? I love these speakers. There is a question here. We have a question online by Mark Urban. How are you, Mark? Mark works in Red Clara. Yes, this is a very interesting question. I think you'll like it. Can't you contemplate the university Granma in Roma to give I'm sorry. Mark is asking whether you could integrate this system that you developed with EdROM. Well, let me be honest. I don't know that system, but we are open to any type of changes and integration. I'd like to push this further. Perfect.